Hello everyone friends, today I'm making a video that will focus on the fairly high-level concept of parameters in the Procedural content generation plugin. I would like to make 3 warnings. Firstly, the video is suitable if you already know the plugin approximately and have already become familiar with it. You can do this using the videos, the link to which I will leave in this description. The second point is that the plugin is currently under development and it's quite possible that some concept will change there with the release 5.2. So the currently primary video should not be complete, accurate and certainly not absolute. Well, thirdly, there is basically no documentation on this part and there are no videos either. Therefore, as the after I carried out further research work, and of course I may be wrong at some points. If you notice my mistake, please write to me about it in the comments. I will try to improve. So, to begin with, let's give a short introduction about the eternal structure that is important since many conclusions follow from this that you will apply in the development. So, the most key aspect is for us is the procedural graph. There is a graph that we edit and which is responsible for the creation of all objects. It is actually served by many different objects that are tests, systems, pins, but they are not important for us. The more important thing is that a graph has a PCG node. This is essentially an empty blank as content that is determined by PCG settings. PCG settings is just all node, all of different types, that is what they are. Respectivity node is just an empty blank. Settings defines it as a node of some types. Note that our settings is inherited from the PCG date. This is the most key object. This is essentially an abstract class of any dates passed to your graphic engine, process, and in other words, about the whole content, we have a certain type that just shoots a pseudo. It can be vector type, it can be point, and so on. Now, from the expanded between settings that exchange the dates. There are currently 2 types of them. The initially included engine in PCG params, which is responsible for all parameters, and the spatial data class, which all possible descents. This is class responds for most points. Well, in principle, for splines, for points, for anything that can be converted into points. And this logic is pre-written for all spatial dates that they can be converted to the successor of PCG point respectively. There is, let's say, the ultimate opportunity. At the same time, we note that spatial data, like param data, also has the PCG metadata entity. Metadata is generally that set of various kind of attributes that we, if necessary, can add to spatial data and remove them absolutely and completely dynamically. For this, there is a separate settings called execute blueprint, and at the same time this refers to a separate blueprint thing class, which is future processed using in the context. Actually, this is a brief description of entire procedural content generation system. Now let's go to the engine and see in details where these entities are and how they are used. So let's begin. Let's create folder. Let's create a graph. This is our main entity. Our graph contains nodes. For example, surface sampler. It can not only be surface sampler but also descent, execute blueprint, and also, for example, execute subgraph. In fact, however, the difference between these three, although everything seems to be node, but is perceivably that they have different. Let's create a new blueprint element for the execute blueprint. And here we can set the general logic of the behavior of a specific blueprint in a specific graph in various ways. So to begin with, that is input and context. Context is, in principle, a generalized entity which also has information about which node and a specific blueprint will be executed from ACT. And inputs is directly the entities that are fed to our graph, the most basic option for how to take inputs as get inputs. And now we can take the specific inputs from the ones supplied to this specific blueprint element. But at the same time, we always take into account that kind of entity we have, which one exactly exists, is supplied, and what order it will be supplied to this blueprint element. For example, this could be cast to spatial data, or this could be cast to parameter data. Each of these entities has its own moment exactly how we can process it. Now we will look at spatial data. The most basic point that can do this can be obtained. As I said, everything we can convert it all spatial data to the points data. That is, decompose into points. Will it be spline or spatial? We can do this using data. Don't forget to submit the context here. And now we can either use one of the loops that can be overridden in this blueprint the element and call it from here like this. Or we can take and edit the point directly. However, what is the worth considering here is that again the points contained only the most basic information about those points. Now let's look at working with the attributes directly in graph and blueprint. So now let's see how to work with attributes. Well, attributes can be added in blueprint and directly in the graph. If I start by showing you the method from the graph, it's quite possible that it will last of your entire long career. And then we'll move to more details that change in the blueprint. Firstly, here each of the nodes that edit our attributes in one way or another That is, each node that details with metadata. All these nodes are present in a separate folder called metadata. There is lots of nodes here. I will try to talk about the most popular and frequently occurring ones. Let's start with this banal example. Let's say I have an ordinary field of particles. I want to add some parameter to it. That is done using the add attribute node. This add attribute node allows you to add a parameter with any name, either using, say, some value or by manually specify the attribute value. We'll look at this with the help of an inspector. In order to use the inspector, we first need to set our selected component here, which we need to inspect. And secondly, we must press the R button to select the inspector through the menu. Now, as we can see, each point have been assigned the SSS parameter. Now, let's take a closer look at how it exactly works. To set this parameter manually, we can use the property toParamData node. It allows you to read some variables from our actor that directly on the procedural generation component, or this is a create a node, which is essentially like a make literal in blueprints. It allows you to cleanly create it or any attribute of any type. Now can call it a specific name and then put it here. So we see. Now let's set some variables, for example 25. As we see, the all name of our S is equal to 25. I would like to note that not the attributes themselves, they also can be presented into the inspector, and this is not always necessary one attribute. There is like parameter data and in general data implies that we can use several attributes at once. Here we have an example that using the combined parameter data node allows you to make two attributes at once in one parameter data. Of course, we can also, with these parameters, filter them in principle, do what we want. I would also like to tell you about one small flaw. All nodes of the metadata class are poorly displayed when searching for their name. That is, either you fill in metadata and here you specifically look for which node you most needed, or you look for this whole thing thought directly without pulling out the pin from somewhere. So let's say we have a certain S attribute. Let's say I want to add it so that we have attributes of various kinds added in different ancestors. For example, that we have one type, one filtering with attribute 100 and the second with the attribute 200. There is a small bug now. I will show you We have two nodes for combine our point data. There is a union and merge. For some strange reason, union does not work as initially would like. This may cause bugs in the future when processing metadata, so I strongly recommend you using merge. Moreover, it, in principle, achieves a similar effect and allows us to more correctly combine metadata. So we see now have parameter of s with a value of 100, part of us with a value of 200. You note also that, of course, if necessary, we can add some additional parameters here in the future. Metadata can also be read. We read it from all metadata. We can't read it from all metadata, unfortunately, but we can do the interesting thing. Namely, we have two nodes, reduce and get attribute. What is difference? Get attribute from point index allow us to get a specific point and read its specific value. Reduce allow us to get a general idea of the points. Here we can choose which attribute we need to receive, what it will be called as output. That is, if we have something at this moment when we display this attribute, it is no longer marked with our original name, but with a new name. Consider it, keep that in mind. Also get various of kind description of these metadata. This could be the maximum value where we see it is 200. It could be the minimal value, or it could be average value, which we have near 46. Now let's discuss what actions we have performed with operations. Which all parameters we can perform a lot of different actions. The metadata class allow this. The settings metadata class allow this without problems. I'm going to do it. Let's go through these sets. Bitwise is essentially mask. Honestly, most likely you won't use this. Boolean thing, which allows you to get Boolean values or Boolean parameters horizontally. If anything, you can indicate the need here. Compare allows use to get a Boolean value, which is essentially a local if. Allows you to get a value regarding exactly how you, under what condition you want to get true or false. Math is probably your main node. This is the ultimate thing for any addition, subtractions, and so on for flat vectors of their values. Combine is separate thing for rotors, and it allows you to do not only combine but also in principle a number of other actions. Of course, all the actions can be found here. As you can see, there is actually quite a lot of them in advance. Compose is the same but for transform, and our trick performs an action with trigonometry. Well, of course, for a vector separately there is a cross, which allows you to calculate cross, distance, normalize them, and so on. Now let's talk about various auxiliary things that you may need when working with parameters. To begin with, this is the rename attribute. The rename attribute allows you to rename a specific parameter to another parameter. Honestly, I don't think this is you will actually need it, this thing, but if they give it now, take it. Why not? Let's try it. As we see, our S was renamed to attribute A and still retained their values. The second point that may interest you here is reading individual dates from tables. And note that we get them by a specific row name in exactly the same way, for example, we got them by index. Attributes can also be filtered. In order to filter them, we have two nodes. The first one simply filters them based on the selected attributes, while the second one can filter them based on the value. There are also two nodes whose meaning I am unfortunately didn't understand. If you know them, please let me know. And so let's now continue and find out how to read data from blueprints and write them down if necessary. We can out both the attribute and the metadata, but the blueprints have one trick which I will show you now. I remember some test example here. Let's start with how to read the data. So we have a series of nodes, all of which comes from input from execute with context, the main function, while allows us to interact with all these things in different ways horizontally. So the first one is now get params at get inputs. The main difference is that getParams displays only parameters from all pins connected to node. getInputs all spatial data. Please note here that a number of important points for all such node. With us, one pin can include several dots at once, and you must take this into account. We also have a duplicate for each of these nodes, will allows you to read specifically from the pins by name pin. That is, for example, you can read from the first pin and the second pin separately. Otherwise, they will be a single array and far from being unambiguous sequential version. There is exactly for the params. Target data has the same node, but at the same reads all data, such at stack. Get all settings. I still haven't found what is used for, but I have idea. So let's now continue it. Please start with spatial data science. This is the main data that you will basically need. Let's start with a basic point that can actually help you a lot. Most of some different settings that duplicate names of the nodes from various metadata and other settings. For example, create attribute, duplicates, create attribute from metadata. Add attribute is more preset. And at the same time, it almost similar to the original add attribute. And what the important advantage, if something happens, we can click on it and see its logic, which give us incredible scope to read and look at the examples that Unreal developers provides us. So let's just start with spatial data. We read spatial data from the first pin. To simplify, I just take everything get inputs. Then here comes the fun part. With spatial data and in principle with any data we can get so-called mutable metadata, and it can be provided as mutable and constant metadata. The only difference between them is that one const and other is not const. What's great about metadata is that it's the main tool for how we can add various attributes. We can I show you later some interesting thing. However, this is where the fun begins, since we directly can add the method directly, but it has a nuance that this leads to numerous bugs. in the system. For example, if we give an example now, let's show later what kind of bugs there are. Therefore, the main tool that we initially use to create a new point data using the construction object from class node, initialize it using the old date. Moreover, this can be done, for example, copy Pullery metadata or using the corresponding nodes in spatial data. And then adding the nodes we need here, for example, some double attributes or something similar, and then running the whole thing in the point loop, which we can now need to add a specific date on a specific point separately. That is, we create an attribute here, create the date attribute that we have, and then in the point loop body we go through each of the attributes, initialize metadata and create it specifically for it and set value for this attribute. If we decide to just take and, for example, leave it like this, and then remove the points loop from us, then we will also set metadata, but will simply be for a single value. So now about working with metadata. We actually have a lot of nodes to edit here, but I will point out the really basic ones. So add attribute actually allows them to be great importance here, since there are quite a lot of them. Since, for example, we can, as we have already said, we can need to add attributes by creating them. But add attributes allows you to transfer metadata from the specific one. Well, transfer attribute from some when another metadata. Copy attribute allows us to copy an attribute from where else you are. Add attribute does not allow us, well, it does not copy the value. Copy attributes creates and copies. It's important. Clear attributes allows you to clear a specific attribute. Get attribute allows you to get attributes accordingly. So that, for example, you can attach them somewhere in the future. Not only attribute, but also the attribute types, mind you. Has attribute check if the attribute exists. Common attribute to get common attributes has set allows us to check the set attribute, that is, wherever a specific attribute with a specific name has non-set value. Also, of course, we have the ability to get any attribute using get, select any types of attribute, and also get the attribute set these attributes using also the name and the specific point.
Here it's worth nothing one important detail which we will consider later, that we can perform a set of an attribute not only using the name and by dot, but also using the so-called metadata key. What's different is that metadata key allows us to use it literally super columns, which is more precise by line, which allows, for example, for parameters that do not have the assign of the point with this without any problems.
Well, enter them, for example, enter this whole thing into circles or something like that. So, I asynchronously deleted a little bit, but everything is correct now. What about the number in the description? It says that this node allows us to copy, save attributes for, well, let's say further rendering, but to be honest, I don't yet fully understand how it's specifically affect the code. So use it, why not? Now let's talk about editing mutable, editing parameters directly, and what this entails. And this is furthered with cute numbers errors. But first, let me show another example, namely with parameter data. Param data is basically the same for us. The only thing that we can't do this, firstly, we don't have node to initialize mutable metadata. Well, our new deposit thought the old node. In the same way as spatial data. I use initialize as copy works almost the same way. Now, thanks to the case, we can add deleted metadata. In this example, in this version, we go through a cycle. In each cycle, depending on the number scrolling loop, we will have a different number of our lines. Let's check this now. For example, now I set a little. I can set more. I can make 100 if you want, live on any kind. By the way, let's check our spatial data. Don't forget to turn on the inspector. As we can see, we have set R with this value. Now, this means, of course, it is also possible, for example, to do this for a single line. Set, create, count, something like that. We see here we do not use loops like we had an example as spatial data. Now, about the bugs. Actually, let me show one of them. There's the spatial data. Yes, let's even remove it now, since I've already managed to introduce a bug here. Let's set up a test and run it. I have two experiments. The first is we directly create a new point data and output it, and the second is when we try to add something directly. So that means we turn on inspector and see now. First, we can't use add attributes by key on spatial data with some reason. And the second, we can't set attribute using key on spatial data as you see. And the second bug, let's change our experiment in second. Our values put in previous node metadata. That means that our new variables created, but old variables is same. And if we can't remove it with changing experiment, we can also remove it only removing previous node. If we work with the parameter data, we have same problem, but a little different. In this example, you can see what happened if we add values in previous metadata using case. Every update, if I add new rows, that bugs means that I'm not recommended you to put metadata to a previous metadata or do it on your risk. So that was all the information that I know at the moment about working with metadata. If you like it, please write it about comments. I will try find more information about it. Thank you.